Okay, so I think we can start now. Thank you again, everyone that has joined the webinar. Again, a reminder that you can at any time write any question you want in the question box, and yeah, I will try to answer them all at the end of the presentation. So, no, I will be your speaker today. My name is Gorka Arrieta, and I've been part of the product team at RatedPower for 3 months, and I'm going to be guiding you through this webinar about hybridizing utility scale PV plants with DC Coupled BESS. And we're going to be talking about the benefits of DC Coupled BESS, also how to define DC Coupled BESS with pvDesign, and then we dive deep a bit into our methodology, and at the end, a sneak peek about features that are soon coming to pvDesign, and a Q&A session. So before getting into the benefits of DC Coupled BESS, I want to tell you a short introduction about what is DC Coupled BESS. So DC Coupled BESS, or DC Coupled Battery Energy Storage System, refers to a storage system where the batteries are connected to the DC side of the PV plant, and there's no inverter in between the solar modules and the batteries. So if we were to charge the batteries, the current will flow directly from the modules to this thing called DC to DC converter that basically just adjusts the voltage of the electricity, and then this will go into the battery directly, and it wouldn't be until we were to dispatch this or to discharge this battery that the current will go into an inverter, the same inverter that is used by the PV plant, and then just convert it to AC and consume or inject it into the grid. Now, if we take a look at the planned projects of different countries for the next year, we see that there is a very clear trend towards building hybrid projects. We see countries as diverse as Japan, Poland, Chile, the UK, the US, and Australia leading this trend. And for example, in Chile, we see that PV projects hybridized with battery systems are expected to grow 19% year on year until 2026. So yeah, they are trending. And why are BESS projects trending, right? What is this a thing right now? Well, we have the main reason for this is that we already have a very high renewable energy penetration, and it will continue to grow on the next years. And renewable energy, it's characterized by its high intermittency. What does this mean? Well, this means that the renewable resource isn't available at any time. It fluctuates a lot during the day or during the weeks, and it might not be available when we need it. So this leads to mechanisms to store the generated energy, right, to the need of storing this energy so we have it available whenever we need it. And one solution for this is to use battery energy storage systems. So now that we know what battery energy storage systems are and why is it trending, let's dive into the benefits of DC coupling. The first one will be oversizing. We know that oversizing is something that is commonly done in the solar industry because modules are not always producing at maximum capacity. So this leads to oversizing the DC part versus the inverter maximum power. And this also leads to when the modules are actually producing at maximum capacity, there is excess energy that cannot be converted by the inverters. So this is when the DC coupling BESS gets all his benefits because you can use this excess energy to charge the batteries, and you have this energy available for later use. You also have the affordability because yes, DC coupling is going to be cheaper than using AC coupling BESS because it uses less equipment. And it's also going to have a higher efficiency because it only needs one conversion from DC to AC, right? While the AC coupling BESS needs 3 conversions to get to the final user. So this is for the benefits about DC coupling BESS. Now I want to show you how you can design a layout with using pvDesign and implement this DC coupling BESS in your design. So we have here a demo, a test case. We're going to implement this solution. So this is a very simple design, just one available area with one substation. So what we need to install DC BESS is just to select central inverter, because we don't allow right now the string inverter with DC coupling BESS, so central inverter, and we don't need any battery area or anything because all the containers and all the batteries are going to be installed inside our solar plant. So we select central inverter and we can now go to the battery tab and activate this. And once we have it activated, we select DC BESS. And we can now start defining what is going to be our main equipment. This will be the DC to DC converter. We can define the maximum power of every single converter and how many converters there are going to be per inverter of the PV plant. So in this case, we put 500 kilowatts and 2 converters per inverter. So this makes it 1 megawatt of conversion power per inverter, and this gives us the BESS to AC ratio that basically it's like the charge and discharge capacity versus the conversion power to AC. That in our case is 0.4. This number is basically this one divided by the inverter power, which in our case is 2.31 megawatts. So next, power conversion, battery container. We can define the capacity of our container. We can do it by directly defining the capacity of a single container, or we can do it by racks. We can define the capacity of a single rack and how many racks do we have in a container. Then we define the BESS requirements. This is how many containers or how much capacity do we want to install in our design. So this option, maximum capacity, what it does is installs batteries or containers in all main power stations of the PV plant, only in main power stations, and a specific capacity you choose, you select how many power stations you want to be installed with batteries. So in this case, if we select one, we will have a maximum rated power of 2 megawatts. And this is because if we go to the equipment tab, we see, here in power station, we have defined a main power station with 2 primary inverters. So we have per power station 2 inverters, and we have per inverter 2 converters. So this multiplied by 2, and that's the maximum conversion capacity that we have per power station. And then we can define the supply iteration. This is basically the time that it takes to fully charge and discharge the battery at maximum power. So in this case, we have a 2 megawatt hour capacity of the battery, and we have 2 megawatts charge and discharge power. So this will give us 1 hour of supply. If we were to choose here 2, this means that we are installing 2 containers per power station. We should have here if we multiply this by 2, 4 megawatt hour divided by 2 megawatts of discharge capacity, this gives us 2 hours of supply duration. And we can continue to change this, and up the limit is 6 right now. And last, C rate, this is like the charge rate, which is basically 1 divided by the number of hours. So if we choose 4, for example, this will be 0.25, right? And if we choose 1, this will be 1. Okay. And last, we can also define the dimensions of our container. We have the length, the width, and the height. We can define this as we want to. And then we have the distances. So let me show you this diagram where we have all the distances that we can define. We have the distance between containers. We can define also the distance between container and structure, between container and road, and between the container and the power station itself. So these recommended values, by the way, these are by default, and these are the minimum security values, distances recommended by the US National Fire Protection Association. I think it is the name, yeah, the NFPA. So I think that's everything you need to define the BESS system. I think we can now click on Run Design. This is going to take a few seconds. And if we click in Overview, yeah. So here we see, if we take a look at the legend, this blue, darkish blue is the DC BESS container, and we see that it just installed one in one power station here. This is because we choose a specific capacity. If we here Google and choose maximum capacity and run again the design, this should install battery containers in every power station, well, in every main power station. And we see that it installed containers in every power station, except for this one that I suppose it is not a main power station. So you see, as simple as this, very, very simple to add your battery system to your design. And then you can go here and download all the documentation that you need. Obviously, you can, I don't know, access whatever you need here for your battery system, the design report for the battery system. You have also your energy yield results, where you can see how much energy there is going to be available for charging to your batteries. You also have your single line diagrams and so on. So very handy and very easy. And now if we go back to the presentation, let me go through all of this because this is what we just saw. And now I would like to do a poll question. I want all of you to participate. And the question is, how many of you have used BESS in your designs, even if it's not inside pvDesign? And you can answer the poll right now in your box here. I'll give you 1 minute to answer and we'll see the results. Yeah, I see mostly AC BESS. Okay, yeah, so Most of you haven't used it yet. I invite you all to try it in your designs if you haven't. But for the rest, I see most of it is AC BESS. Makes sense for me, for what we've seen in the market and people use. And yeah, okay, fine. Perfect. So let's continue. Yeah, let's dive deep into our methodology, because there's some things that I want to comment with you that I think that you should take into consideration when designing your system with pvDesign, because this is things that we do, that our methodology is like this, and you should take into account. First of all, battery containers that are only installed in main power stations. This is something you should consider, mostly because, for example, the other day I was trying a design. It was a very, very small layout with only one inverter, and I was trying to install DC BESS on it, and it wasn't installing any container. And the thing is that the main power station was configured to have two primary inverters, and the whole plant only had one. So the software was only installing secondary power stations. So it was not installing BESS because of this reason. So if you ever come with this problem, just remember that you can change the number of primary inverters per power station, and this may fix your problem. Then we have the specific capacity that also, when you select this, the containers are always going to be installed in the power stations that are closer to the MV point. So as using this image here, the MV point is right here, and containers are only installed in these two power stations that are the ones closer to the MV point. The same happened in the demo that I just did. When I choose one, the container was installed in the power station that was closer to the MV point. Then the ratio, the BESS to AC ratio. So by default, we give a 0.5. It's like the recommended value, but it is for no reason in particular. This is just something that we saw when we studied multiple real cases. We saw that a common range for this value is between 0.5 and 1. So I think that that's the range that you may be wanting to use. Higher numbers, so higher ratios for BESS to AC, will benefit from higher DC to AC ratios, because obviously the higher the DC to AC ratio, the more excess energy that will be generated, and it won't be you won't be able to convert it with the inverter. So the higher the BESS to AC ratio, the more capable you're going to be of capturing all these excess energy. So yeah. And then there's also the case when you can have this ratio higher than 1. This means that you're going to be very capable of capturing and charging battery, but you won't be able to fully take advantage of the discharge power, because the inverters of the PV plant are going to be limiting you on discharging the battery. But there can be the case where this is useful. And the 1.5 maximum, this is just a limit that we put, because it's not very common to have a number higher than this. And finally, 2 points. First one is that the battery containers are always next to the power station, and they're going to be aligned the same as the power station. So if you have the power station inside the DC field next to the structures, it's going to be parallel to the structures, and if you have or parallel to the road. And if you don't have roads, and this is outside the the power station, it could be parallel to the perimeter. But this is something that you cannot change through the BESS configurations, but in the power station configurations, because they are always going to be aligned. And lastly, just for you to know that if you have a case like this, where the containers are inside the DC field next to the structures, and you have a perpendicular road, the power station is going to be always next to the road, so it has direct access, and the containers are going to be around it. And with this, we arrive to the final part of the presentation, to the sneak peek and Q&A. So first, I want to be sharing with you what's coming next quarters, and you may be now laughing because there's only one thing there, which is the power factor for AC coupled BESS. But yeah, this is something big, something that people has been asking, and it is, for those of you who don't know what it is, it's basically taking into account the BESS system, the AC coupled BESS system, for the power factor requirements. Because if the PV plant right now has a global requirement for the power factor, the BESS is not taken into account right now, and it should be taken into account to comply, in order to comply with this power factor for the PV plant. And there are more things coming, but I don't want to get my fingers caught here. But yeah, probably energy dispatch strategies. We are working on it, and we are thinking of it. It will come eventually, and also well, with it, all the financial analysis and financial KPIs that also people want us to get into the software, and they are going to be very, very big updates. So with this, I think we can go into the questions, into the Q&A. So I don't know if you have written any question in the question box. If not, you still have time to write the questions. And give me a second so I can open this. Okay. So I see one. If the AC to DC ratio of the PV plant is related to the power factor, it is actually not related. You can have whatever DC to AC ratio, and the power factor couldn't be affected by it. The power factor is more something that you need to comply with in order to inject power to the grid. And yeah, you can, well, it actually, I mean, they are related. It's not that they should change if one changes and the other one not, but depending on how you measure the power factor and the AC to DC ratio, yeah, they will be related. So the lower the power factor that you need, usually this is a very technical question. I'm sorry. I don't think that I can answer it right now, but if you want to, you can. I can get in touch with you by email, and yeah, we have plenty of methodology speaking about this, about the power factor, because I know that is a complicated thing. So I invite you to take a look at it. Another one. Are there any downsides to DC BESS? Yes, of course there are downsides, as with everything. One of them will be that it is less flexible, so it is harder to install DC BESS, for example, in a PV plant that's already been built, because you need more space for it inside the PV plant. That most of the cases it won't be available, and also it is less resilient, let's say, to any problem and any failure, because DC and DC BESS, the PV plant and the batteries, they share the inverters. So if an inverter breaks, you are losing both systems, the PV plant and the batteries, and this is something that it won't happen in AC BESS. More questions? Yeah, it does works in projects smaller than 0.5 megawatts. Just be sure to check this thing that I explained about the main power stations, because you might be facing this issue where you want to install batteries, but it does not install any because you don't have a main power station in your design. So always check that you're installing main power stations, because, yeah, the answer is yes, it is possible. No, my model was not showing solar panel facing east-west. It was they were trackers, so it was a tracking system, which is usually oriented north to south. That's where they were. You were seeing a vertical line for the structures, but it is actually possible to create an east-west oriented system. More questions. Is it possible to use string inverters with DC BESS? Yes, it is possible. It is actually possible, but we haven't implemented this option yes, because it is possible, but it is a bit strange, because even if you were to use string inverters, you will need to put all the string inverters in a single, let's say, power station to put it next to the batteries, or at least this is what we've seen in real cases. So for now, I think that the option for central inverters it's good, but for sure it will come on next updates to pvDesign. Okay, and I think last question, why would I want to use BESS to AC ratio higher than 1? Well, in most of cases, you won't, because what I say about that you will be wasting discharge power because of the inverter limit, but there might be cases where you have so many excess energy generated by the DC modules that you may want to be able to capture all of this energy, even though then you won't be able to discharge the batteries like at full power, but you are still capturing all this excess energy. This will happen usually in very northern or very southern countries, when they have less hour of light, and they use the oversizing of the plant is more common. Okay, there's a question, one last one. If I could recommend further resources to learn more about commercial PV battery energy storage systems. Actually, in RatedPower's page, we have a knowledge base with a lot of information about PV and BESS, and it is very easy to follow, I would say. It is very well explained, and it is not necessarily linked to our software. So I think it's very good for you to learn and to get more in depth about PV and BESS, which I think it is a very, very interesting topic. And yeah, so I think there are no more questions. So I think we can close it here. So thank you everyone for assisting. I want to remind you that on the January 10th, we have another webinar with upcoming product updates. So you're going to be all welcome, and you are all invited to come. So thank you all for joining and for assisting. Thank you all for your time. And I hope you have a great day, and see you on the next one. Bye-bye.